Hello, yeah, in this video, I will talk about how to assess the stability of clusters in a cluster analysis, actually k-means clustering, using an R package called FPC. Okay, so the purpose is to generate a simulated data set for k-means clustering, and then use an R package called FPC to assess the stability of the clusters. And the methods in FPC are based on bootstrap methods. So the background is we know cluster analysis is not like really exact. It's shaky based on the data. The cluster you get from a cluster analysis may depend on the data, the method you use, or the distance you use, etc., etc. There are many variables that make the clusters you get may not be stable. Okay, so there's a need to see how reliable or how stable the cluster you got from a cluster analysis. So here we're just gonna use the k-means as the clustering method. Okay. All right. First, let's load in the necessary libraries. One is mass for generating normal data, and the other one is the FPC for cluster stability assessment. The first step is to set a random seed and then generate a data set with 3 clusters. They all follow normal distributions. Okay. And put them together. Name the columns. There are 2 variables, an X and a Y. Treat it as a data frame, and this is a data structure look like. So there are 2 variables, and you have 100 observations. Okay. The next one, let's do k-means clustering. Set a random seed again, and then using k-means, center is equal to 3. And then we assign the k-means result cluster to the data frame data and save it to a variable called the cluster. Okay. And then now we assess the stability of this cluster using the FPC package. Okay, set the random seed again, and we use the R function cluster boot in FPC. Okay, so you can see the syntax is cluster boot, and your data equal to 1 to 2. That's the original data set. And the cluster method is k-means CBI. That's a wrapper for k-means. And there's 3 clusters, 100 bootstrap resampling iterations, and the boot method using the boot. Okay. So as we know, bootstrap generate bootstrap samples that mimicking the sampling variability in the data. So you will get many different bootstrapped samples, and you perform different cluster analysis, and that's how you assess the variability of the clusters, and then you define a metric for stability of the clusters. So let's first print out the stability result. You can see it has this result give you a bunch of information about the cluster method, number of resampling unit, etc. 3 clusters. What's really important is this Clusterwise Jaccard Bootstrap omitting multiple points mean. Okay, so you get you have 3 clusters, and each cluster has a Jaccard Bootstrap Mean here. Okay, so little bit notes on the Clusterwise Jaccard Bootstrap Mean. It is a metric for stability of a cluster. It ranges from 0 to 1. The higher the value, the more stable is the cluster. And there's some rule of thumb thresholds. If the Jaccard metric is greater than or equal to 0.75, usually we consider the clusters are highly stable clusters. Okay. If it's between 0.6 and 0.75, then it's a reasonably stable cluster. And if Jaccard is less than 0.6, then it's an unstable cluster, likely to split or merge with other clusters. Okay, so for this example, we got 0.99 and 0.989 and 0.99. So all 3 clusters are very, very stable. Okay, so this is one way to assess the stability of clusters using k-means. And of course, we can make it more formal to print out the result of the bootstrap mean. And also we can use ggplot to print out the cluster here. Okay. All right. So this is one way to assess stability of clusters in the cluster analysis using the Pakcage FPC, and we choose the k-means as the clustering method. Okay, and you can use it on other clustering method. Okay, so all right, and I'll continue to explore some other ways for assessing stability of clusters in cluster analysis. This is a very important topic. Thank you.